Thank you, everyone. I will be speaking in English. Hopefully, everything will be fine. And if I go fast or something, just raise your hand and I will try to slow it down. So today, I'm going to talk about animations in Flutter, but we will go from like super basic and we will see how you can implement animations. We will cover some basic concepts of Flutter and we will see some code and explain how you can do such scenarios. So let's start by the classic like about me part. I am Mohamed Salih Güler. I am a Berlin-based Android engineer who works for a company called OneFootball. And I'm a Flutter and Dart GDE. I've been developing Flutter since the like later alpha days. And I've used Flutter in my pet projects, real projects, and like, yeah, I've been into this world for a long time, so I know I can say that I know how it works, more or less. So, I will start with the classic question, like what is Flutter? Who has heard about Flutter? Like, who has any idea what it is? That's the answer. And yeah, like, so Flutter is actually like, you can think it as a new kid in the block that is an alternative to create cross-platform applications. I'm not using cross-platform mobile applications because Flutter supports desktop and web, and of course iOS and Android. So how it is supporting it? So Flutter is an SDK, and it is used in Dart language. It has been, as you said, provided from Google, and they started off with like providing you a software development kit with iOS and Android. And as time goes by, they wanted to use the same code base for desktop and web. And for seeing an example, for example, the slide, not the slides, but the presentation that I'm using right now is a Flutter desktop application. And I use the same code base and upload it to this address. And you can see that it works as a, is it from me? Okay, shame on you. Anyway, so it works as a website as well. So you can actually see that it is working. It is in the developer preview, so it's not 100% ready, but you can see that it is working. You can upload it and you can use it for simpler approaches. So we are going to be using this Flutter application to show the scenarios, and I will show the exact same code that I used to create those animations. So let's talk about why animations are important and why I would like to talk about it. The thing is, as an engineer, as a developer, you need to care about your users. And users, I mean, we mostly develop for humans, and humans are visually driven creatures. So you can put a text of like 10 pages, they wouldn't care. But if you put a simple animation, they would understand everything faster and easier. So a well-known, well-taught animation can educate people way faster than multiple lines of written text. So that's why you need to understand how these animations and how this system works. And plus, since we are, again, visually driven creatures, you can just take an app, and if it has a nice animation, you will feel like, okay, I mean, I might use this app. It has a nice user experience. So that's why we need to care about animations. Now, let's dive into the real subject, animations in Flutter. So in Flutter, there are basically two types of animations. One is tween animations, and the other one is physics-based animations. So tween animation itself is basically, a tween word means in-betweening. So you need to give a beginning and an end value, and you can interpolate in between these values and create a visual approach. Physics-based animations, they're using the real-life physics rules that you learned probably in high school or university, and they bring you a user experience that you can provide with for example, Newton's law of physics or some other rules that you would probably remember from your physics lessons. So we will dive into these two topics. Now we will start with the tween animations. So for creating an animation itself, you need to understand what should you be using and how should you be using. I will explain some base concepts for this, and I will show the code actually how they work. So animation itself, animation object is the base object for your animation approaches. It is a primary building block. It provides you the value that you can use to do something on the screen, but it doesn't know what's going on the screen. And it doesn't have any controlling mechanism over itself. So it just generates some values according to the values that you provided for beginning and end, but it doesn't do anything extra. You need to have some helper classes to make the whole operation. As I said, it has some status in it, but it doesn't know like how to start generating. For this, we need to have a controller mechanism. We need to have an operator, and for this, we are using animation controller. It's a special type of animation object. It gives you control over your animation objects, so you can use the same controller for multiple animation objects. And with this one, you can provide what is your animation generator type, what is the duration of your animation, and what are the values that you need for this. And animation controller object itself is, as I said, an animation object, and it also accepts a beginning and an end value, but only in double. So you can use it to create animations. So, no further ado, as you see, we have a fade transition animation here. So basically, you can think it as an opacity from, let's say, fully visible to not visible. You can think it like from 0 to 100 if you're an Android developer, or you can think it from like 0 to 1 from other platforms. So we are going to see how you can implement this with the code. So basically what we have here is, we have a stateful widget. Widget means there are two types of widgets that you can use to create your Flutter applications, stateless and stateful widget. Stateless widgets itself, they are immutable. So you need to have some logic to make it mutable, to change the values on the screen. So that's why you have two types. One of them is stateless, another one is stateful. We are going to be using stateful to change the logic or something on the screen. So since we want to change the visibility of something on the screen, we will be using a stateful widget. So what we are doing here is we are creating a stateful widget. When we create a stateful widget, it will ask us to override a method called createState. So it will ask us to create a state class. And this is how you can create a state class. You just give the name of the class and add the state, and you should provide the stateful widget that is asking for this so it can find its way, let's say. And afterwards, I will get back to this, but first, as you see, I created my animation controller object. If you want to initialize an object during the initialization of a state class, you can override the init state class. And afterwards, we are going to create the animation object here. We say controller equals animation controller. It requires at least a one vsync variable. And I will explain this with the ticker provider now. And you can provide a duration. And what I say is I can add a listener to the animation object or animation controller to have knowledge about when I created an animation, in each frame change, I need to have an input. So I can recreate this view again to show the current status of the view. So what I do here is, in each frame change, I'm resetting the resetting the state. But I missed this part. Like, what is vsync? So, as I said, you can listen to each frame change, but you need to have a bridge between your frames and your Flutter code. So we need to have a logic. We need to have something providing us a ticker that is giving us that, okay, your frame has changed. You need to update something. And this is you need to change your animation value inside of your animation class, like because something has altered. You need to have something new, and ticket provider provides us this information. Ticket provider itself can be like single ticket provider is basically it says, okay, I will be taking care of one animation controller, giving you information about something has changed during the animation frame process, and it will give you back it will give back a callback to your animation controller. But you can also use this with multiple animation controllers, and for that, you need to just delete this and say only ticket provider state mixin. We will see those examples as well. So, like, just let's roll with it. So, when you create the state object, it will ask you to override another method called build. Build method is the place that you create your views. So for this purpose, what I did is I said, okay, I will use the opacity widget because in Flutter you have almost everything for the use cases. So if you have, for example, if you want to change the opacity, you can have it. If you want to change the padding, you can use the padding widget. So that is what we are doing. We are going to be using the opacity. And for the opacity value, it changes from 0 to 1. 0 means invisible, and 1 means fully visible. And as I said, animation controller itself is providing a value out of the box to us from 0 to 1. So that's why I say, okay, use the current value of the animation controller. Because when there's a frame change here, I'm setting the state, and I'm recreating the view here, and getting the current value of the animation controller. And in here, basically, I added like tapping behavior. So like this part is totally unrelated to animation, so we can ignore it. But this part here itself is a bit important. Why is it important? Because we want to have the, like, as you remember from the animation, when I click on it, it like toggles itself, goes from 0 to 1 or goes from 1 to 0. So I can check if the animation is completed, I can reverse the behavior. Or if the animation in the starting status, I can restart it again. So that's what I'm doing here. I'm checking the status, and as you see, you can like, there are like other statuses as well. If it's dismissed, it means that it's in the starting position. Okay, you can't see it because it's too small. So if the animation is completed, then everything is done. Every value interpolation is done. If it's reversed, it's in the reverse method call, but it's not done. If it's forward, you started the animation, but it's not done, and this means it's in the beginning position. I know it's too much information, but when you see it on the code, I think it makes more sense. Like when you're in the completed state, of course, you would go back to the beginning position. So this is how we implemented the tap behavior. And last but not least, there is a method that we should be thinking to implement called dispose. Dispose method itself is, so if, like how many of you are Android developers? Very few. So in Android, there's a problem called memory leaks. So if you don't handle the memories carefully, or like memory visual stuff carefully, they might just cause some problem in your memory because they will occupy some memory that shouldn't be used, and it might cause some performance issues. But if the view is not visible, if it's not used at all, then logically you should just dispose everything and keep that memory part fresh and free for the new operations, right? This is what we are doing here. Dispose method is called when a widget is not visible, like when a widget is killed. So when you're making an animation, like before the animation ends, if you kill the widget, it should just free up the space that is holding so you can use it for other operations. That is what we are doing here. So basically with the 50 lines of code, you can create the view here, everything here, and like have the tap behavior and creating the animation. But as you see here, this doesn't seem like right, because like recreating the state each time might be expensive, and it is expensive. If you don't handle everything carefully, if you don't care about the performance, it might cause some glitches or lags on your screen. So what you should be doing is, you need to either handle it yourself carefully, or you can let Flutter do it for you. And Flutter has something called animated widget for this. Animated widgets are like, they're the special kind of widgets that you can use to create single purpose animations. So you will just create the value interpolation for it, and it will deal with the set state and like listening to the controller and everything itself. So this way you would have more performant approach, which has been provided to you from Flutter. Flutter itself comes with a lot of out-of-the-box animation widgets that you can use. Like, there are animated padding, slide transitions, opacity widgets that you can use to create animation objects with high performance. But if you don't want to have it, of course, you can create your own animated widget itself. But let's continue. As you see, this is the exact same animation. And let's check the code, what we have done here correctly. So if I come here, I can see that stateful widget creation is exactly the same. I'm creating a state class here, exactly the same with the ticker provider. I'm creating an animation controller, exactly the same? Not, because I don't have the listener here, as you see. So I don't do the set state here. And what I'm doing here is, I'm using something called fade transition. What fade transition is doing is, it takes the animation object from you and says, okay, I'm going to deal with everything. Like when you start the animation, I will just interpolate it and show you the view that you needed. Nothing more, nothing less. You don't have to do all the other stuff that you need to do. So you can just give the child view that you want to animate to the fade transition, give the animation object, and the set state and listening to the frames will be done out of the box from the Flutter. So this way, you can have the same behavior with like getting rid of the set state and the add listener thing that might cause some performance issues. With the simpler approaches, I know it might not cause it, but when you have like staggered animations with multiple different approaches, it might cause some glitches. You can see it with the benchmarks and other stuff. So let's keep going. I mean, right now, so far we have only seen value interpolation between 0 and 1 and how to do it with animation controller. But what if we don't want to interpolate it in between numbers? What if we want to interpolate in between curves or colors or rectangles, or even the position of the widget? What if we want to make something more creative? So for this stuff, you need to create twins. Again, same meaning of the word. Twin means in-betweening. So it expects some type of value from you, and it will interpolate your values from the beginning to the end. Most of the classes in Flutter comes with a method called lerp. It's like linear interpolation method. So basically, you can use most of the classes actually to create a twin object out of it. You can, for example, you can use the color class to create your own color twin, or some other one that you want to have. I don't want to fall down. Anyway, so this is what it is providing to us. And let's talk about curves now. So again, so far everything that we see was happening with the linear interpolations. Like you can have beginning and end value, and like it will interpolate the value linearly from 0 to 1. But what if you want to have something fancy, like fast out, slow in, and other stuff that interpolates the values in a different way that gives more exciting animations to us? So for this stuff, we are using curves. Curves are, again, you can create your own, but Flutter comes with almost like 20 different curves, so you can use it in your project to create the animation itself. So what we're doing here is, so you can check like different types of curves. Okay, next time I need to be careful because they're not readable here, but I will read it. Like for example, you can have the bounce in behavior, bounce out behavior. You can have an accelerating behavior or decelerating, or like ease on, ease in, slow out, etc. So you can have different out-of-the-box curves from Flutter. So what we are going to do next is, we are going to be creating, so as you see, I have two buttons here. One of them is showing down, one of them is showing up. So when I click here, I'm having this coming from the top edge of the corner, and it just bounces. And when I click up, if I can see it, yeah, it just like does the animation in reverse. So that is what we are going to implement now. Because as we see here, it gets slower at the end. Like it jumps and getting slower and like finding its place. So let's see the code for this. Again, like when we, like this is visible, right? Everybody can see it. Okay. So when we create the stateful widget, again, the same logic. We create it here with a stateful widget object. Again, here we are creating the state class with the single ticker provider because we still have one animation controller. Nothing has changed so far. But with this one, I'm doing something different. I'm saying that, okay, change the offset of the of this element with the animation object. But what does offset mean? In Flutter, offset means changing the position of the element from its initial position. So when you put an element to somewhere in the screen, you can change its position according to the pixel numbers that you have. Or not the pixel numbers, sorry. You can have a rectangle around it, and you can put it to the regarding edge of the screen. So left edge means, let's say, -1, and the center is 0. Top edge means -1, I think, and the bottom is 1. So you can think it like this. We will see it in the values as well. So what we are doing here is, we are creating the animation controller as we did before. Only difference is I'm changing the duration to the 1 second, so it is more visible. And what I'm doing here is, I'm saying, okay, yeah, one thing to mention that I forgot to mention is offset gets an X and Y value. So it expects you to have in the XY coordinates system. So center of the screen is like 0, 0, and if you go top, it's 0, -1, because you're in the same X coordinate, but you are in the Y coordinate, you are a bit up. So you say offset is 0, -1, so you start from the top edge, and it says ended at the 0, 0. So it means ended in the center. And after that, Tween itself is not an animation object. It's an animatable. So it's something that you can use to animate. So for animating it, you are calling a method called animate. And it is accepting, again, another animation object. You can give your, if you don't want to have the curved object, you can just give the controller here. But we want to have the curve, like we want to have this nice jumping behavior. So what we are doing here is, we are creating a curved animation and giving the controller here, so it is doing the orchestration for this animation object. And for the curve, we say elastic out. So it's like, it will be going down and getting up really slowly. And this is how you create the animation object. Let's see how you can use it. So this stack widget and the position stuff is completely for creating the view. What we care about the most is this part. Because what this doing is, it is using something called slide transition. And let's check what slide transition is. As you see, it's an animation object, animated widget, sorry. So as you remember, animated widgets are accepting an animation object and animating the child according to the value coming from that. So I'm giving the animation object here and giving the child to just animate it, and the rest is totally done by Flutter itself. So only by doing this, you are making this nice, and of course doing this part, you are doing this nice looking animation here. Like as you see here, it looks like really fresh. And because of Flutter's Skia engine, rendering speed is really high that like Skia promises 60 frames per second for devices, and if you have the supporting device, it supports up to 120 frames per second. But minimum, it supports 60 frames per second, but only for right now desktop, iOS, and Android. If you see it bad in web, remember that it's in the technical preview. I can show you actually. Like as I said, same thing happening here, same Flutter class. But if I do this, as you see, it's more glitchy here. But in desktop, it's more fluent, I think. But yeah, anyway, let's keep going. So far we have only spoken about the single-purpose animation scenarios, right? Either it's a slight transition or opacity change or something like this. But like these are the implicit animation. Yeah, these are like implicit animations. Like they are doing one single purpose, nothing more. I hope the wording is correct. But there is another animation type is called staggered animations. So you can have different types of animation happening either simultaneously or happening in a way that they are like cutting their time frames somehow that at the same time, for example, you can change the orientation and color. And for doing this, animated widget is not enough because, as I said, animated widget is proposed and purposed in a way that you create single-purpose widgets. So that's why they created something called Animated Builder. Animated Builder itself is basically using the same logic with animated widget. So it is handling the set state and other stuff that you provide, but it expects an animation controller, and it expects, again, a child that is going to be animated on the screen. For using it, basically, we are going to be creating an animated builder class. It will ask us to create a builder function, and when this function is created, it's just going to create this return value that we are going to be providing to that. So let's check out how we can do this. So basically, there's a box here, and when you click on it, it splits into 3 different, let's say, columns, and rotates and changes its colors to Flutter colors. So how did we do this? How did we provide this? Let's see the code. I'm starting every time from scratch, from the top, so you can see that actually the pattern is more or less the same. Like just creating some stateful widget and going around the animation objects, just to give you the example of how you can do stuff more complex. So I'm coming here, as you see, this is exactly the same, nothing different. And one thing that I mentioned was, as you remember, was like animation controller can control multiple animation objects. And as you see here, we have like a lot of them. So we are going to be controlling and interpolating all of these from one animation controller. So let's see how we create these values. So first, we are creating an animation controller object exactly the same that we did before, nothing different. And height, angle, and margin animations are animating double values, interpolating double values. So what we are doing here is we are creating a tween saying that, okay, just interpolate from the 7 to 45. Why do I do this? Because actually this box thingy consists of 3 different boxes. So each has a 7, sorry, 70 height. So what I want is, I want to make them shorter. So I can split them, right, and make them more natural. So that's why I want to change its initial height from 70 to 45. Again, as I said, tween was animatable, so I need to animate it. I'm saying that, okay, this is the animation controller that is going to control this. One thing different here is, I didn't use curve. I used something special here. It's called interval. For the interval's sake, all of your animation is a timeline from 0 to 1. So you can control and arrange your animation controller to arrange this animation or interpolate this animation in this timeline in only some part of it, in this timeline's only part of it. So if it's 0 to 1, you can say that, okay, for the height, make it happening only from the 20% of its timeline. So finish it quickly than the regular one. So this is what we are doing. It is going to be starting from the 0, but it will finish quickly than the other ones. Same thing happening for the angle animation. What I mean with angle animation is, as you see, it is rotating. So we need to be rotating this as well. And for this, again, from 0 to 0.25, because for the sake of one round, it is 1, from 0 to 1. So making it only quarter return, it's 0 to 0.25. And again, starting and end point is the same, like the one before. With Dart, you don't have to put the 0.0s. You can put also 0. It's working fine. So don't get confused by why is it different in this and this. It's basically, I just forgot to put it probably. So lastly, there's a margin animation. Why do I need a margin animation? I made the thing smaller, right? But since they are together in the beginning, if you make them smaller, they will be together anyway. So for making them splitting, you need to also put them a margin. So actually, in the meantime, they are getting smaller. You're making a gap in between. So it gives you the feeling that actually they are getting smaller, but not moving at all. That's why we are giving this margin animation. And the color, as you see, we have 3 different types of color animations. And the reason is, as you see here, it gives you 3 different type of animation, color animation. One of them is more light, the other one is more darker, and the one that is super dark. And all of them are starting from white, and one of them is interpolating itself to the light, the other one is interpolating itself to the medium, and the last one interpolates itself to the dark. But as you see, interval of this is different. It is happening after the splitting happens. So, there is, as you see, when I create the boxes, they return and move to the center, right? How do we create this behavior again? So for creating this behavior, we are going to be using the same slide transition logic that we had before. We are going to be given an offset, and this offset will be moving this to the center of the box. But one thing to be careful about offsets is, as I said, for the sake of offset, it only cares about the height and width of itself. It doesn't care about the screen's offset. So for its own behavior, the center is itself. So if it goes to the right edge of the screen, it means that actually it will go out of the right edge of its limits. So that's why when we are implementing here, we just say again, it's 0, 0, and it will go to the center, which is actually the real center of the application. But in here, as you see, it goes to the -1. So actually, they are going to the right edge and the left edge of their screen. So this way we have created our animation objects, but we haven't used them so far. And when we use them, I know right now it's too much information, I'm bombarding you, but actually they are all patterns. Like when you're at home or something, just like go over it once and you will understand like, actually they're happening in a pattern. So let's create the view. And so with the animated builder here, what we're doing is we are using a rotation transition, one of the animated widgets that we have. So it takes the angle animation here to make the rotating happen. We are using the slide transitions to make them move in. And lastly, we are changing the height and width inside the container. We have also animated widgets for this, but since we are in the animated builder, the set state is happening itself, so we can actually use directly height animation's value in each frame change to change the height and width of the box that we have. So when you create this, like you have the slide transitions and height and width are happening, margin and color are happening in the container itself. So slide transition uses an animated widget, but this itself is using the components from a real widget, not a dedicated animated widget. I need to wrap up really fast. So this is like, again, the same behavior here. So let's continue with the physics-based animations. As I said, it is using the real-life behavior from the physics classes. You can see there's a gravity simulation, spring simulation, and in here I just provided a free falling. I mean, it is one of the basic physics laws. Like, if you don't have any friction, if you leave a ball, it just like accelerates in a different way, let's say. And as you saw, it was like going faster as time goes by. And for creating this, what we did here is we have used a gravity simulation. You can provide an acceleration to give an initial speed or not. It's totally up to you. You can have the starting position and ending position because you need to give some boundaries to it because it will only calculate the physics laws behind it. And lastly, like when you give a starting and an end position, it will just interpolate, it will just calculate it and change its speed according to the physics laws. And like if you click on it, it is going to explain like what is it using, from which physics laws and stuff. So finally, I want to talk about Flare. Flare is a really cool tool. It's a 2D vector animation tool that you can use to create really nice animations. Like one of the examples is this one. So it works really nice. It gives you creativity. There are open source parts that you can use as well. I created this for here. Like basically, it can like smile, wave, move the antennas, and flirt. You know, this is what it does. So it took like if you can use Paint, you can do this stuff because I'm a terrible visual artist. So if I can do this, I'm sure everyone can. And lastly, like I want to give a really fast conclusion. Animations are really important, and with the Flutter's graphic engine and everything, it gives you a fluent experience in multiple platforms. They are not hard. With the declarative UI, you can have your UI and animation in the same page, and really, really with short amount of code. Like the longest code that you saw here was like 150 lines, including the new lines with the parentheses and everything, which is, I think, highly acceptable. So like, do not be afraid to implement the animations in Flutter. They are like easy to understand, easy to implement. And I will pass this one. One thing that I wanted to show really cool is that you can run different kind of applications in Flutter applications. For example, this is a mobile application running in desktop application. So there is a mobile app for this. I just put the widget here, and it works out of the box fine. So Flutter gives you all the flexibility that you need for a lot of stuff. So you can just go ahead and use it and basically play around with it. I mean, for what to do next, you can find me afterwards, or we can make a Q&A really fast. So sorry for fast wrap up, but thank you for listening to me, and thank you very much.
И, ребят, теперь у нас есть время для нескольких вопросов. Задавайте вопросы, причем можете на русском, если что, не стесняйтесь, я переведу. Да.
Hi.
Hi.
Okay. Can you hear me? Okay.
Yeah.
You mentioned that you use Flutter in production application, and I'm wondering, did you notice any problem, performance issue with animation in your application?
This is okay. As I said, like the thing is, when I develop applications with Flutter, I use the platform like developer tools to check if it's performant enough and do something according to make it better. So when I was optimizing it, I was able to do it and I didn't have any issues. And with, for example, I worked on a meditation app in Germany, and like basically this app had some animations, and we were testing it with like low-end devices with S4 Mini, and they were working fine. So it, like, depending on how you implement it, it can be laggy, but if you do the, like, animated widgets are simple touches actually, but they affect a lot. You should be careful about how you recreate your state objects so you can have more control over it. And this way you can optimize it. So when you optimize it, it works perfect fine. And optimizations doesn't mean that writing extra code, as I said, like using animated widgets, or like there's a bit more complex approach called keys in Flutter. You need to use the keys carefully, and then it works really well.
Okay, so it's doable to achieve 60 frames per second, yeah?
Yeah.
Yeah.
Mm-hmm.
Okay. Sure, thanks. Thank
Yeah.
you very much.
No worries.
Еще вопросы?
Okay. I don't want to listen to you. No. Yeah.
Thank you, Mohammed. It was amazing
Yeah.
talk. I have a question.
Yeah.
As I understood, you have prepared your slides in Flutter for Desktop.
Exactly.
Could you tell what should I do if I want to do something on Flutter for Desktop? For example, if I want to make application for web, I should download special kind of SDK, Flutter for web. Or what about Flutter for Desktop? Is this open sourced or is special preview for GDE?
No. So let me explain this situation. So there are two ways to do it. One way is to, like right now, Flutter Desktop is merged to the Flutter master. So you can use the master channel. I don't recommend it because it is the most flaky one. Or what you can do is, there is a, let me quickly show you. Flutter Desktop. There's this Flutter Desktop embedding GitHub repository. It's open source from Google. You can just clone the project and play around with the example part of it. And you will have your desktop application. But bear in mind that the code is not here, not ready yet. So it can take up to, I don't know, like end of year or so. I don't know the date. So it can take some time.
Nobody knows.
Yeah, I mean, like, the thing is, everything happens simultaneously. Like, no, asynchronous, let's say. Like, everything happens at the same time there. So we don't know which one will come first. They are working in the different teams. But I know that this is one of the priorities because they care about it a lot. Like, when I used it first time, I used it in Japan, and I can tell that back then it was only supporting macOS. Now it supports all the platforms. So there is some progress going on for sure. But is it production ready? No.
And will you share your source code?
Yes. Afterwards, I will share it.
Thank you.
Ну что, у нас есть время еще на последний вопрос. Напоминаю, что за вопросы мы даем магнитики понтовые, и это один из пунктов в квесте. О, вот у нас есть вопрос.
Thanks for your talk. My question is not about animation. My question it's about you as Android developer when you switched.
Did I do that? I'm sorry.
When you switched from Android to Flutter, which type of problems you faced?
I mean, like, so there are three different answers that I can give. I will give all of them quickly. First of all, there are, of course, like, I'm telling the same thing to everybody. I will tell it here again. Flutter is not the answer for everything. So in my previous company, I was developing a sound test engine, highly used in C++. Flutter doesn't have C++ support yet, so I can't use it. I can't force someone because it means that I need to write platform channels for everything. I need to write the app actually 3 times, one for iOS, one for Android, and one for Flutter, which doesn't make any sense. So I don't think that it's the answer for everything, but I think it's a good alternative as an answer, as a cross-platform approach. So when you have the right use case, when you use it, the hardest point for me, not hardest, but for me the point was getting used to a new language and like using declarative UI, because with the declarative UI, if you're not careful, you can just put some logic inside of your view and it's not testable, so it can be a bit dangerous, but it's a matter of experience, right? Like as you get used to it, you know it, because I mean, declarative UI is a good approach. You can see it from iOS started with Swift UI, Android started with the Jetpack Compose, you know, like they are bringing new stuff, so you can actually use the declarative UI really fast. And like moving towards was easy for me because I was able to implement things super fast because, for example, I hate the Gradle waiting time. I mean, right now I'm back to the Android development because of a project, and I wait like, it's a huge project and it's not well maintained, so I was taking over it and I wait for like 10, 15 minutes Gradle times, which is like annoying. I just put it, go get a coffee, talk to my friends, and come back, it's not ready yet. So the advantages like this are making me happy. And Dart itself is actually like getting better. It looks like more Kotlin actually. As time goes by, they got rid of the new keyword. They are bringing the extension functions and everything that the community asks for. I mean, you still have the same column, but it's not the end of the world.